Hey class, this is Professor Jeff for Civil Engineering Materials CE 200. We are going to begin with week 2 of our class. I thought I would wait till next week to go over week 1 when we are in person so that we can go over any questions you might have about the syllabus and the structure of the class. So we are going to dive right into the reading material that will be assigned for next week in going through an introduction to civil engineering materials. So our agenda for today is the background of materials, projects and materials, materials used. We're going to talk about 2 categories, metallic and non-metallic, along with their histories. We'll also touch on failure modes, which you'll also be learning a little bit more in the lab, and then we'll summarize with takeaways that are to be used on the quizzes as you encounter them. So a little bit of background. When we are talking about materials for civil engineering, we're talking about considerations for the selection of materials. They could be structural needs, or basically this is what the customer wants. And sometimes the customer wants some pretty crazy materials. This could be influenced by socioeconomic factors and fashion trends, as we'll talk about some of the interesting finishes that we'll encounter. There are some environmental constraints oftentimes. Sustainability is another area that is emerging as we look at how buildings maintain or sustain themselves, and from an energy use standpoint. We'll talk about production, transportation, and construction priorities, mechanical properties, how well the materials hold up with loads, and then non-mechanical properties, which tend to do with aesthetics. Of course, all of these materials will cover all the branches of civil engineering, and they are integrated into the different phases of a project, which we'll talk about an application a little bit towards the end. But what I wanted to hone in on is a little bit of the public works, because and transportation, buildings, and then systems. These are all the areas that we're going to encounter in our careers. Public works are basically those things that are kind of behind the scenes that you don't really pay attention to. Roads, the utility systems underneath or above the roads, the transportation, whether we're talking about bus, rail, air, or other control systems, and then buildings and facilities, whether they're low-rise, high-rise, or medium-rise, and all the systems that we use to provide safety and all of the needs for humans to enjoy life. Moving into the elements of civil engineering, these are the choices and the compromises that we make when we're selecting certain materials, which really gives us the full range that we're going to talk about. So as we get into the history of materials, there's 2 categories, metallic and non-metallic. And when we think of metallic, sure, it goes back to when civil engineering began. There's a reference to it beginning with copper, and then eventually becoming bronze. What's interesting about the Bronze Age is the Bronze Age is actually a composite of copper and tin. And it's still a mystery to archaeologists today as to why the Bronze Age precedes the Iron Age, because bronze requires mining of materials and then amalgamating it into a product, which seems to be a little bit of a sophistication jump to just come from Stone Age, but it is a bit of a mystery. Iron Age, which follows the Bronze Age, simply using iron ore, oftentimes found on the surface of the earth, did not take much work to locate, but once found, melted, and then molded into the shapes that were needed. And of course, today we use steel, aluminum, our primary metals, and there are other composites and extrusions that are done. Now, I'd like to pause for a minute and using some of my background, talking about the Walt Disney Company, where I spent 8 years of my career. And you'll find that all of these materials that we're talking about, those we've already touched on or those to be touched on in this lecture, come to play. And of course, we talk about dreaming a project. This is where some of the ideas and how it comes about. And we know with Disneyland being the first theme park of the Walt Disney Company in 1955, had really came out of a dream by Walt Disney. And of course, by the time my career started to unfold with the company, it was back in 1996 when California Adventure was being planned. And of course, there was a tremendous amount of design looking at a whole variety of materials and how those materials would be transported, recycled, and reused. And when I say recycled, it all began with the parking lot that existed on the south side of the Disneyland theme park. And the team I was on was a team of 500 individuals. That was for the design, not including construction. Construction added another 500 to 1,500 employees. But during the design phase, we had to consider, where are we taking some of the asphalt materials, the rock? What about some of the earth or the soils that would be transporting, either making mountains or excavating it out of roadways? And in fact, this was one of my projects, Disneyland Drive, where we had it coming off of the freeway. We had to run it over Ball Road. We did some excavations where we actually put it under a downtown Disney bridge. Materials were used to balance with those on the site. And of course, as you look at this photograph, you can see all the things that come into play, whether it's asphalt, soils, concrete, landscape, metal for signs, and so on. And it doesn't stop there just in terms of building the public works or the massive logistics. It also gets into the park. And so one of the projects I had was renovating the Disneyland Railroad. And of course, everything is about steel and mechanical systems and renovation of existing infrastructure. I even got involved with rehabilitating Walt's legendary historic apartment, which sits on Main Street above the firehouse. And again, it was going into preserving the architectural theming and the historical aspects of it, and how does that get placed into new service? And of course, we had to consider the range of materials, not only that were there, but the ones that were now the new materials to be applied. And so with that, it summarizes a career. And of course, while I was there, I was awarded a brick that was placed in the Esplanade entry area to either of the theme parks with my name on it. And of course, the brick is another civil engineering material that we'll talk about in the next property. So we get into non-metallic. And of course, this is making mud bricks. Now, the brick that I have at Disneyland is not mud. It's a cementous material, but it's nonetheless still referred to as a brick or a paver. And so the ancient Sumerians began with mud bricks. The Assyrians employed them. Of course, the Babylonians did. The Romans also invented, and we call it so-called Roman cement, but it's a hydraulic cement that was made essentially of pozzolana, which is a volcanic ash. Ironically, this cement, we still haven't quite figured out what it was, because it lasts 2,000 years. And even though the Roman cement that was directed by the British Parliament to be built was in fact a very different material, because it only lasts 150 to 200 years. We also have timber and asphalt that were used in some of those ancient civilizations, and even during the Byzantine Empire, natural asphalt was used as a binder in masonry mortar. And so we also have large rock or riprap, which is used for basically levees and protection from water elements. Plastics are now being introduced, and soils and glass and aluminum are also part of the range. Now, when we talk about the failure modes of these, when we're talking about steel, there's either no failure because it's holding up just fine, or it gets warped, or it gets modified, it changes shape. Concrete is brittle. In its term of failure, it cracks and spalls, and we'll be talking about that more in the weeks to come. So our takeaways from today's lesson is basically the background of materials, project materials, the two categories that are used, metallic and non-metallic, and the failure modes, which we'll talk more about in the next weeks to come and also in the lab portion. With that, we'll see you next week.